will now look at the last concept in class 10th constructions, and that is construction of tangents. Now in the circles chapter, we've already discussed what a tangent is. A tangent is basically a line which touches a circle at one unique point. When there is a circle and the circle is touched by a line at only one point, that line is called a tangent to the circle, right? So now we're going to learn how to construct tangents, right? We're going to look at two kinds of constructions. First is that when we want to construct one unique tangent through one point. And second, based on that, which we need to know that for other constructions, the second is going to be construction of a pair of tangents. Okay, construction of a pair of tangents from an external point. Now let's try to learn this, right? First of all, the first thing which we're going to learn during construction of tangents is construction of a tangent through a given point. On the circle. Now, for example, you have been given a circle and you know that you need to construct a tangent through a given point on that circle, right? You know the radius of the circle and everything, then you need to do that, right? Pretty simple. Now, for example, you have been given a circle of radius, some assume 4 centimeters. So 4 centimeters radius of the circle, right? You need to now construct a tangent to through a point on that circle, right? Any unique point, right? So the first thing I'm going to do is construct the circle. So first draw the circle. Okay, let me draw a better one. So first of all, we are going to draw the circle. So this is my circle, suppose. Okay. Now we know to draw, and suppose the center of the circle is O. We know that the radius of the circle is 4. So after drawing a 4 centimeter radius circle, we need to draw basically a tangent through this point, suppose P, on the circle, right? So you know that P is any point. You can take it at any point because obviously you know OP. So first of all, how will you construct a tangent through it? So first of all, you can join OP. So first join OP. Once you join OP, you want to draw a tangent through OP. Now you know from the circles chapter that a radius is always perpendicular to the tangent at the point of contact. Now you know that here P will be the point of contact of the circle because you want to draw a tangent through it. Now basically what will it mean? It will mean that OP will be perpendicular to the tangent through P. OP will be perpendicular to the tangent through P. That is, it will make a 90-degree angle. So can we say that if I construct a 90-degree angle here at P, then that will mean that will give us the tangent? Yes, because OP is perpendicular. If I draw a 90-degree angle through P, then definitely that line going through P will be the tangent through P for the circle. So let us see how we do that. Pretty simple. You can do it now. First of all, take P as center and you're going to construct an arc. You're going to construct one random arc. Once you're done constructing the arc, take this point where it's meeting OP, suppose some D, and take D as center and construct another arc with the same radius as you took this. So with the same radius, cut an arc, and take this as center now, and with the same radius, cut another arc. And then with this as center, cut one arc here, with this as center, cut another arc here. And then you are going to join this P to the point at which these two arcs meet. So suppose this is some Q, right? So you're going to basically extend it up till wherever you want. And then you can even extend this backwards. So if you construct this backwards, now you can see that this will be a line, right? So you've drawn a perpendicular through P, which is on the circle, and it's perpendicular to the radius, right? So you can see this is a 90-degree angle. If you do it accurately with a compass, it will come 90 degrees. So you can see this is a 90-degree angle, right? So basically you can say that this PQ is a part of a tangent through P. So you can say, suppose this is some L, you can say L is a tangent to the circle, right? So this is how we construct a tangent through a given point on a circle with a given radius, right? So you constructed a tangent, pretty simple. Construct a 90-degree angle, you can construct a 90-degree angle, you can construct a tangent, right? So I'm not giving the steps here. It's pretty straightforward. I hope you're clear with it, right? How we construct a tangent through a given point on a circle with a given radius, right? So that's what we're going to do. Why I've taught you this is because in many questions you'll need to do this. You'll need to construct a tangent through a point. So that's why you need to know how to do it, right? When you do it with compass and scale, it'll come accurate, perfectly accurate, if you do it properly, obviously. So that's with my first thing with construction of tangents. The second thing which we're going to discuss, which is discussed in detail in your textbook, which takes a lot of time, is construction. Okay, construction of a pair of tangents from an external point to a circle. So basically you've been given a circle of some radius, right? You need to construct a pair of tangents to that circle from an external point, from a point which is outside the circle, right? So how do we do that? Let's see. First of all, let me take any random example because taking examples is the best. First of all, we need to construct a circle with that given radius. So for example, the radius of the circle is given as 5 centimeters and that point, right, distance of the point from the center, let OP be the line joining the center of the circle and external point P. So let me assume that external point is P and OP is the line joining them, right? So this OP distance, the distance of the center of the circle to that external point is given as some maybe 9 centimeters. Okay, suppose it is given. So now we need to construct a pair of tangents to the circle through P, right? So how do we do it? The first thing is that you are going to construct a circle with radius 5 centimeters. So first of all, construct a circle. First of all, construct a circle of radius 5 centimeters. So suppose this is my circle of radius 5 centimeters, right? Suppose that's my circle. And this is some O center, right? Now, circle of radius 5 centimeters. Now we need to take a point P outside the circle. So now you're going to, take any random ray through O. Any random ray, I mean to say any random ray you take through O, suppose OX. And then OS center and 9 centimeters as radius, cut an arc. So you can say that this P will be my point, right? Because you know OP is 9 and you've cut an arc at 9 centimeters radius, then OP will be 9 and P will be the point, right? Which you need, at which it meets OX. So that's my P. So we've located point P. I hope you got how we located point P, right? Very good. Now from P, we need to construct tangents. You'll say, oh, it's so easy, just draw 2 lines. You can't do that. You need to draw proper, accurate tangents. So how do we do that? Now, you have got point P. Now you want to draw tangents through P. Let them be P and PP. You want to draw those tangents. So how do you do that? First of all, take OP. Here OP is very crucial. Take OP and construct the perpendicular bisector of OP. So you're going to construct the perpendicular bisector with that. For that, you take P as center and radius more than half of OP, as you've done in earlier classes. Cut arcs at both down and upward areas. Okay, so down and up, cut 2 arcs. Then OS center and the same radius, cut this and this. Right? So with that, you have got 2 points. You join those 2 points. So once you've joined those 2 points, you'll get the perpendicular bisector of OP. Let it be at some D. Okay, so OPD equal to DO and this is perpendicular. So we've got the perpendicular bisector of OP. Right, so we've constructed the perpendicular bisector of OP. Yes, very good. Now comes the crucial part. DO and DP distance are equal, right? So now you take D as center and DO or DP as radius. Take any of them as radius, right? Then take D as center and what your textbook has done, okay, leave that for now. DO equal to DP. Now take D as center and DO or DP as radius. Any one of them as radius. Cut two arcs on the circle. So you're going to cut two arcs on the circle, right? So suppose this will be meeting the circle at A, and this will meet the circle at B, right? What your textbook has done is that they have taken D as center and constructed circles like this, so that they meet at 2 points, right? That's what your textbook has done. I feel that's not required, because you just want to find the points at which they meet the circle, right? So you can do this also. No need to construct another circle. That's sometimes just a waste of time. Okay, so basically just cut two arcs and you're going to get your 2 points which you need. You don't need this part, right? You just need these 2 points. So cut two arcs with that as radius, colors finished. Now once you're done with that, let me just get rid of these points which we don't need. Goodbye. Shabba khair, take care. Now you have found A and B because you took D as center, DO or DP as radius because both are equal, and construct two arcs here which meet the circle at A and B respectively. Now the last step of this, which will give you your tangents, is take P and join PA. Join PA. Oh no. Join PA and then join PB. So you got your two tangents, PA and PB are the required tangents to the circle. Right? So that's it. Over. Right? You constructed a pair of tangents to the circle, right? So basically, that's your steps. First, you construct the circle of that radius. Then you take any random ray going straight, right, till some x. Then take the distance or between the center of the circle and the point outside the circle, that is the exterior point, take that as radius and cut an arc on OX. Then that's your P or whatever your external point is. Then you need to construct the perpendicular bisector of the line joining the center and the external point that will meet at some random point between them. Then take that as center and the half of the OP or the line joining the center and the external point as radius. So here in this case it's OD. You can take DP also because both are equal, and then take D as center, cut two arcs on the circle, right? Cut two arcs on the circle without modifying the radius. Please make this sure that you don't modify the radius. Then cut two arcs, and then from that external point P, from where you want to draw the tangents, connect the points, right? PA and PB. That is the point at which they touch the circle, right? So I hope that's absolutely clear. You'll get your two tangents, PA and PB, right? So you get a lot of variations in this question, right? Sometimes they give you the angle formed by these tangents, right? Sometimes the angle at which the tangents are inclined. That means this angle is given to you, this angle. So suppose this angle is given, some x. Now, remember this one thing, that if this angle is x, then definitely the angle formed by these 2 points at the center is 180 minus x. It is 180 minus x. This can be proved because if you join A to O and O to B, you know that these two are 90 because radius is perpendicular. So their sum is 360. These two are already 90. So 90, 90, 180. So these two also have to be equal to 180. Their sum has to be 180. So 180 plus 180, 360 because it's a quadrilateral. Now, if this is x, then this has to be 180 minus x. So if this is given as x, then you construct some angle 180 minus x here. Then they'll meet, the rays will meet the circle at some random points. There you construct 90-degree angles. Okay, because that's why I taught you this. That's why it's important, because you need to construct tangents. So construct 90-degree angles and then construct 90-degree angles, then draw tangents. They will meet at a point. That point is your external point from where the tangents are drawn, and then you've got your two tangents. Right? In that way, you've got your two tangents. So in this way, you get questions like this. Please thoroughly practice your NCERT. I've given you the basic way to do it, right? If you still have any kind of doubt, please post it in the comment section below. And thank you very much for joining me. I hope you understood everything. And with this, we conclude the series on constructions. I think the next series will be on applications of trigonometry. So I hope you look forward to that. Thank you very much for joining me. Goodbye. Stay healthy, stay smart. Do keep studying. Best of luck for your examinations. Please send a like and share this video. Thank you.